Heat loss calculations. Week 4B. Construction Principle Unit 1. This week the aims of the session are as follows. Recap last week's the main elements of the building that lose heat and how we can prevent this. 2. Carry out a basic U-value calculation for a solid brick wall using K-values to establish R-value. Last week we discussed what the three main parts of the building that lose heat. Try to remember the main ways how we can prevent heat loss through these elements. The main elements that allow heat loss to occur are through windows, doors, floors, roofs and walls. The main ways how we can prevent heat loss through these elements are by 1. Providing insulation to walls, roof and floor. 2. Providing double and triple glazing. 3. Providing low emissivity glass. 4. Providing secondary glazing and porches etc. 5. Providing draft reduction from unwanted ventilation. 6. Providing low heat loss materials chosen for the structure and fabric. Conduction. Even though there are three forms of heat transfer for a building to lose heat, the most significant one is conduction, as the majority of the heat is lost through the conduction of heat through the building's structure and fabric. In order to calculate the heat loss of a building, we first need to know how conductive the materials are and how much heat loss will occur. The conductivity of each material is known as the coefficient of thermal conductivity. It is known as a K-value. What is a K-value? The coefficient of thermal conductivity, also known as a K-value, is equal the number of joules of heat per second flowing through a material 1 meter thick and meters squared in area for a temp difference of 1 degrees in temperature. There are mathematical expression for these as can be seen on the slide. However, please don't get concerned with these, as in reality, the way we apply these mathematical expressions is far more easy than it looks. K-values of materials. The coefficient of thermal conductivity, also known as a K-value, can be found in a number of construction science textbooks or manufacturer's datasheet. The value for different types of building materials is different depending on the nature and properties of the materials. However, there is one important thing to always remember. A high K-value means that the material is a good conductor of heat and therefore a poor insulator, while a K-value that is low is a bad conductor and therefore a good insulator. Therefore builders, designers and architects should always try to choose materials with a low K-value. Examples of K-values of materials. Here you can see a basic list of K-values. This is an extract from the book Building Construction by Chudley and Greenough. You will have these pages available to you on the college system in the folder that accompanies this slideshow. What you will see is that materials with high density usually have a high K. That means that the material is a good conductor of heat and therefore a poor insulator. An example of this is concrete. While a material of very low density usually have low K values and therefore is a bad conductor of heat but a good insulator. An example of this mineral wool quilt insulation. You will also see that any material made of metal has extremely high K values, as metals are very good at conducting heat due to their properties. Calculating heat loss in a building is a little difficult as the building structure and fabric is not made of just one material, but multiply layers of materials at different thicknesses. So instead of looking at each material separately, we can calculate the building element, such as a wall, as a single value. This will result in a total heat loss value known as the thermal transmittance value or U value. Heat loss calculations. In order to calculate U value of a part of a building such as a wall, we need three pieces of information. The thickness of the materials that make up the wall in meters. The K value of the materials that make up the wall. The total heat resistance for the particular material. This is known as the R value. To calculate the R value for a particular material, you can work this out using a simple formula. The thickness of the material divided by the K value of the material equals the R value of the materials. If we then work out the R values for each material that make up the wall, and add them together, we can calculate the total R value for a wall. Finally, we can work out the total thermal transmittance value or U value of the wall by using a simple formula. 1 divided by the total R values equals the U value. Wall example 1. In this example you can see that the wall is made up of 3 different materials. A 15 mm layer of plaster internally, a 215 mm layer of brick, and finally a 15 mm layer of render externally. Therefore, to work out the total thermal transmittance value or U value of the wall, we must first work out the R values for all the 3 elements. We then add all 3 R value together to get a total R value, and then work out the U value by dividing 1 by the total R values. Wall example 1 continued. In this example you can see that we have indicated the separate R values for 3 elements of the wall. A 15 mm layer of plaster internally has a K value of 0.57. Therefore the R value is 0.026. A 215 mm layer of brick has a K value of 0.84. Therefore the R value is 0.255. And finally a 15 mm layer of render externally has a K value of 0.57. Therefore the R value is 0.026. If we add all these 3 R values together and divide them into the number 1, we will have a U value. Wall example 1. However, there is one factor that we have not considered in the calculation. Though most of the heat loss through the fabric of a building is through conduction, not all the heat that is conducted through the wall will instantly be lost to the outside air, as the heat would have to be transported to the air by means of convection and radiation. Therefore we have to add R value into the calculations to allow for or compensate for the convection of the air and the radiation. This is known as the RSI and RSO for inside and outside of the wall. Examples of RSO and RSI R values. Here you can see a list of R values to allow for conduction and radiation both on the inside and outside of a building. This is an extract from the book Building Construction by Chudley and Greenough. You will have these pages available to you on the college system in the folder that accompanies this slideshow. What you will see is that there is a RSI value for inside walls, floors and ceilings. These are usually set at a value that does not change. You will also see that there are RSO values for external walls and roofs. But you have a choice to decide if they are in a sheltered or severe exposure position, and also whether they are these have a high or low emissivity value. Normally we just use normal exposure and low emissivity values for standard calculations. Finally, you will see that there are values provided to take in account of voids such as cavity voids. This is because heat will still transfer across a void or cavity due to convection and radiation. Therefore the total R value calculation is as indicated on the page with additional R values for the RSI and RSO. You will see that the U value has changed from 3.25 watts per meter squared to 2.06 watts per meter squared. This is why it is important to always allow for the RSI and RSO in the calculation, as it has a big difference to the value of the U value. As it is complicated to work out the U values using this formula method, there is a much simple way to present the information and work out the calculations. This is using a table format. Table method example 1, walls. What you will see in this example 1, walls, rather than putting the formulas down for each calculation, we can simply use a table to work out the R values, total R value and finally the U value calculation. Step 1. First of all, draw a table of each of the elements including the RSI and RSO. Step 2. Next, draw columns for the thickness of the materials in meters, the conductivity or K value for the material, and the calculated R value for each material. Step 3. Place the thickness for each of the materials on the table. Make sure that you always put the thickness of the material in meters. So for example 15 mm is now 0.015 meters, and 215 mm is now 0.215 meters. Step 4. Place the conductivity K values for each of the material on the table. Remember that they will be provided to you, or you can get them from science books or manufacturer's data. The K value for each of materials is available in the extract from the book, Building Construction by Chudley and Greenough. You will have these pages available to you on the college system in the folder that accompanies this slideshow. Step 5. Work out the R value for each material on the table. Remember the formula. The thickness of the material divided by the K value of the material equals the R value of the materials. Therefore, to work out the R value of the render, the formula is 0.015 meters divided by 0.57 equals 0.026. Continue to do this for all the materials. Step 6. Add up all the R value for the materials and the RSI and RSO values to give you a total R value answer at the bottom of the page. Step 5. Work out the R value for each material on the table. Remember the formula. The thickness of the material divided by the K value of the material equals the R value of the materials. Therefore, to work out the R value of the render, the formula is 0.015 meters divided by 0.57 equals 0.026. Continue to do this for all the materials. Step 6. Add up all the R value for the materials and the RSI and RSO values to give you a total R value answer at the bottom of the page. Step 7. Calculate the U value for the whole wall. Finally, we can work out the total thermal transmittance value, or U value, of the wall by using a simple formula. 1 divided by the total R values equals the U value. The U value is the total amount of heat loss per second per meter squared of wall, when there is a temperature difference of 1 degree centigrade between inside and outside air. If in this example we had a temperature of 2 degrees outside and 22 degrees inside, we have a total difference of 20 degrees centigrade. This is a 20-degree gradient of heat transfer. To work out the total amount of heat loss for 1 meter square of wall, we simply have to multiply the U value by the difference in temperature. Therefore, to work out the total heat loss for a 20-degree heat gradient, we multiply the U value by 20. This gives us a total heat loss of 41.20 watts per second.